Hello, YouTube. This is umills03. In the previous lesson, we learned about if blocks and if-else logic, and we essentially said that the output of our program can basically depend on the values of Boolean variables within our code. And so if some things are true or false, that can basically affect the execution, that can affect basically what's going to happen in the output of the code. And so what we're going to do in this lesson is we're going to develop an alternative strategy for running code that is conditional or contingent upon other information in the program. So what we did and we saw in the previous lesson is we played around with if and else if and else. But it turns out that we actually have other architecture in Java called a switch statement, which works in a slightly different way, but it can actually achieve similar purposes, if not the same ones. So what we're going to do is I'm going to go ahead and describe some of the architecture of the switch statement, and then we're going to go ahead and take a look at a few examples. Okay, so what you're going to do is basically an int variable must be declared and initialized before a switch statement. Okay, so you're talking about basically an int. It must be an int variable, and it has some value associated with it. Okay, and then basically switch of variable or expression will be the start of the switch statement. Okay, and basically what that means is inside of curly braces underneath the declaration of the switch statement, there will be cases that align to possible values of the variable or expression. So let me show you what I'm talking about with that, because maybe this doesn't make a lot of sense. So what I'm going to do is I want to take a look at int q equals 77. And then what I'm going to do is I'm going to say switch of q minus 70. And so this is giving you an example of basically how this would be the declaration and initialization of an int variable, and it has to be an int variable. And then what you do is you're going to go ahead and pass an int into the switch command. Okay, so switch of variable or expression basically must contain an int variable or some function of an int variable. Okay, so you could have said switch of 2 times q, and then you would be comparing 2 times the value of q against the possible cases in this switch statement. But what we're going to do is we're going to say switch of q minus 70, which means that we're going to line up our possible cases with possible values of q minus 70. So for example, maybe q minus 70 is 5. So what we're going to do is we're going to have one case. And so what we're going to do is we're going to say system.out.println of hey, okay? And then what we're going to do is we're going to say case 7, and we're going to say system.out.println of u. And the way that the switch statement works is basically if any of these case values match up with the true value of q minus 70, the true value of what's in this switch parameter right here, what it'll do is it'll latch on and it'll run the code for that particular case and all subsequent cases underneath that case until or unless there's a break statement. So we're going to see lots of examples, but I want to make sure that what I'm saying is clear enough here. So what we're going to do is we're going to say case 5, system.out.println of hey. Case 6, system.out.println of u. Case 7, system.out.println of what's. And then case 8, system.out.println of up. Okay. And then what we're going to do is we're going to have something called a default, and then we're going to say system.out.println of by. And so if we want to have comments and we want to have good documentation here, what we would say is this code runs if q minus 70 equals 5, okay? And then basically the case 6 will run, so code runs if q minus 70 equals 5 or q minus 70 equals 6. So if we match this case value or any of the previous case values. And so basically it's going to try to find the correct case value, and then it's going to run all the cases until the end of the switch statement unless you hit a break. So what we're going to do is we're going to see what the output of this code will be for 5, 6, 7, and 8 and something else other than 5, 6, 7, and 8. and then we're going to add some break statements, and we're going to see the effect of adding the break keyword into locations within our switch statement. So what I'm going to do now is I'm just going to go ahead and run this code. And so what I'm saying is that basically the case 7 is going to be the value that it's going to latch onto. So is it going to print hey? No, because q minus 70 is not 5. Is it going to print u? No, because q minus 70 is not 6. Is it going to print what? Yes, because q minus 70 is 7. Is it going to print up? Yes, because even though q minus 70 is not 8, we said that once one of these case values is the correct one for the variable or expression in question, in parentheses, we're going to run all subsequent cases. So we're going to run that case and all cases below it. So now what we're going to do is we're going to go ahead and compile this code, and then we can run it. And you can ignore the other architecture here. I've actually been filming future lessons, and I came back to sort of redo this one. But what you can see is the console output here shows what's up by. And that's because basically q minus 70 latches on to this case value and will run all cases that are below this case as well. Okay, so that's what happens when we have the case being 7, is we're going to print what's, and then we're going to print up, because case 8 comes after case 7, and case 7 was the successful case. And then default is going to run regardless of whether or not we latched onto one of the cases. Okay, so if q minus 70 had been 2, we would still run by. So let's go ahead and see that in action. What I'm going to do is I'm going to switch q to be from 77 to 75. And now since 75 minus 70 is 5, we actually, according to what I've been explaining, we should go ahead and print all 5 of these things, because if we're latching on at case 5, we're going to run the code underneath case 5 and all subsequent cases until or unless we hit a break statement. So now we go ahead and compile and run the code, and we run the main method, and we get all 5 of the print statements. What if we do int q equals 78? Then we should only expect to run these last 2 print statements. So now we're going to go ahead and compile the code and run it, and we just get up by. What if we say int q equals 82? Well, 82 minus 70 is 12, and that doesn't line up with any of these case values. So now if we go ahead and compile and run it, we're just going to get by. So hopefully that's clear to you how that works. And you can have more than one print statement. You don't have to limit yourself to just one line. So you could say, int r, you can have as many lines as you want. So you could say system.out.println of r mod 25, and so that would print the remainder when r 100 is divided by 25. And so you could print hey and 0 if q minus 70 is 5. Okay, so the only time you would print this code, the only time you'd print this is if q minus 70 is equal to 5, right? We call that like a Boolean. This might be a true or false statement, okay? But then what this u is going to run if q minus 70 is either equal to 5, in which case it's going to run the case 5 code and then the case 6 code, or if q minus 70 is equal to 6, in which case it'll skip the case 5 code, but it will run just the case 6 code, right? And then you'd be talking about these other cases too. So again, if q minus 70 is 6, you run cases 6, 7, and 8 and default. If q minus 70 is 100, you just run default. If q minus 70 is 5, you run everything in here. If you latch onto the first case, you're going to run everything until or unless you hit a break. So I know we still have to talk about that word break, but hopefully you can get an idea of what's going on here. And so now what you do is we could take this back to 75. So 75 minus 70 is 5, and now we could print more than 5 lines of code, right? So we would have the hey and the 0 under that case 5. But again, now if we go ahead and say 75 plus 1, then we're looking at 76, and we're going to lose both of these first 2 lines. We're not going to print hey, and we're not going to print 0 because we're not latching onto the case until case 6. So now if we go ahead and compile it and run it, then you just have u what's up by. And we said that, remember, default runs regardless. So this runs regardless of whether or not one of the case values matched the variable or expression. So if it does, then it'll run those cases and then it'll run by. If it doesn't, it'll skip all the cases, but it'll still run by. Okay, so that's essentially what we have going on here. And this must be an int, okay? So you don't have to just say switch of q. You don't have to pass in a straight variable. That's why I just did the minus 70, okay? It could be any adjustment. It can be any adjustment or transformation or some simple function of an int variable. But at the end of the day, q minus 70 has to be an integer, okay? And these case values have to be integers. There's no way in hell that q minus 70 could be 6.2. So if you go ahead and write 6.2, you're going to have a hard time compiling because it says possible conversion from double to int, and you can't be doing that. You need this is all in the context of having ints, which makes it a little bit more restrictive than talking about an if-else, because if you're talking about comparing values in an if-else block, you could be looking at doubles or booleans. You could look at the length of a string object. But the switch statement is a little bit more restrictive, and so you're just basically you're looking at an int, okay? You need to compare an int against possible values, and if at any point you latch onto one of those values, you're going to run that case and all subsequent cases, and then everything will run the default code. Everything will run the default code, and if one of these cases were true, one of the case values latched on, the default code usually just comes at the bottom here. So now what we can do is we can talk about a break statement. So what we've been saying is that if one of these case values is the correct one, then the code will latch on to that case value and run that case and all subsequent cases, all cases below that case. But that only happens to the extent that there are no break statements. So what we're going to do, I'm going to clean this up a little bit. Let's remove this R mod 25 thing just so that we have one print statement associated with each case. But what I'm going to do is I'm actually going to insert a break statement after case 6, and then another one after case, let's do it after case 8. So now what's going to happen is that if q minus 70 is 5, it's going to run these two cases, but then it's going to break out of the switch statement. Okay, so here what we're going to do is we're going to watch that happen. So we're going to say in q equals 75, and hopefully you can form a prediction about what exactly is going to be printed to the console. So now if we go ahead and run the main method, the only things we get are hey and you, because we were instructed to break completely out of the switch statement after case 6, okay? And so you're not even going to run the default code if you break out of the switch statement before that. And we can summarize that for a few minutes at the end. But now you can run q equals 76, okay? 76 minus 70 is 6. And now we should expect only to get u, because immediately after we're done printing u, we're going to break out of the switch statement. So we wouldn't be looking at any subsequent cases, and we wouldn't be looking at the default block. So that's what the break does there. So what if we said 77? So now we're gonna encounter another break. So now instead of printing what's up by, we would just be printing what's up, because 77 minus 70 is 7, and those are the two cases, you know, from the correct case value until the next possible break. So now we're going to go ahead and compile it and run it, and we just get what's up by. Okay, so then you can go ahead and play around with the effect of putting the break in different places. It turns out that you could actually put the break at the bottom of a switch statement, but this is completely optional. It doesn't really have an effect. It turns out you're going to be breaking out of a switch statement by the time you get to the bottom of it anyway. You know, if you haven't broken out already, once you get down to the default and you print the default code, it's going to break out of the switch statement anyway. So that's an example of an optional keyword, which really doesn't make a tremendous difference in this particular scenario. But yeah, you can just go ahead and see the effect of this break statement, right? So what if you put a break statement here? Well, now if q minus 70 is 5, it would just print hey. But then if q minus 70 is 6, it'll print all of these cases, because after this first break, there's not another break for a while. So what we're going to do is we can try it with 75 and 76. If we run q equals 75, we know that 75 minus 70 is just 5, and then we immediately hit the break statement after printing hey. But now if we go ahead and say q equals 76, we should expect to see a lot more code printed to the console. We get u what's up by, because it runs all those cases until it hits that break statement. And hopefully that's clear to you. And then if we do 80, q equals 80, well then none of the case values are correct, right? Then we'd be looking for like a case 10. But if we don't have a case 10, we just run the default. And so that would just go ahead and print by here. So now if we essentially go ahead and compile this code, and then we go ahead and run it, then that's the only thing that we view there. What we can do is we can formulate a switch statement as an if-else statement. So what if you wanted to basically formulate this as an if-else statement? So what you could do is you could say, basically, you could come up with an if-else statement. This will function as an if-else statement as long as there's a break after each case. So here's what we're going to do. We're going to put a break after each of the cases. So that means that if one of these values is true for Q minus 70, it'll run that particular condition, but that's the only circumstance under which it would run that condition, and it's not going to run the other conditions. We just want it to print one thing on account of what the value of Q minus 70 is. So in order to have a switch statement function as an if-else block, right, where you just say if Q minus 70 is 5, do this. Otherwise, if Q minus 70 is 6, do this. Else, if Q minus 70 is 7, do this, right? And so you want to have that mutually exclusive logic where only up to one of those cases, only up to one of those possible blocks of code can run. And in order to prevent more than one possible block, more than one possible case from running with the switch statement, you need to install break at the end of each case, at the end of cases 5, 6, 7, and 8, certainly. And then we said that the one at the end of default was optional. But now you would go ahead and you would turn this into a if-else formulation. So you would say if Q minus 70 is equal to 5, it's the exact same thing as what the switch statement is doing. So now it would say system.out.println of hey, okay? And then for the next one, you would say otherwise, if Q minus 70 is equal to 6, and you can see that these are called mutually exclusive Booleans. These could not both be true. And in a switch statement, right, we said that once you latch on to like the first case, you're going to run all the other cases, but that's only true if you don't have these breaks installed in here. So now you only run up to one of these cases at most. You either run 5, 6, 7, 8, or default, exactly one of those 5. And so you could formulate the same thing, and you would just say, otherwise, if Q minus 70 is 6, system.out.println of u. Else if Q minus 70 equals 7, right, it's the same thing. So system.out.println of what's, okay, and it's the exact same thing. You should feel comfortable going back and forth between a switch statement formulation and an if-else formulation. So you'd say otherwise if Q minus 70 equals 8, right? And so this would be the last else if, and then we're just going to have the else. We're going to have the catch-all. So it's go ahead and print system.out.println of up, right? And then finally, otherwise, system.out.println of by, okay? And so that's essentially, these basically lines of code have the exact same effect. And you could test that out with different lines with different values of Q. And you could just test that out here. So now if you essentially do, you know, you get what's for 7, right? And then if you do it for 79, that would just go to the break statement. So you would get 2 buys instead. But it's just showing that right now in the current formulations, if you have a break after each case in a switch statement, it would function exactly as an else if. So that's sort of our discussion of the switch statement. What you do is you basically need to have a value of a particular variable. And then you're going to say switch of, and then either that variable or some modification to that variable. But what's in these parentheses certainly has to be an integer. And you're going to be comparing what's in these parentheses against possible values for that integer. If at any point the case value matches that expression, you're going to run that case and all cases below it. But that's only true so much as the fact that you don't have a break. If you have any breaks, you're just going to run all the cases until you hit a break, and then you're going to jump out of the switch statement. And remember that all values will run the default case until or unless they encounter a break before that. And so we said finally that a switch statement could basically be modeled to basically formulate an if-else, right? It could be another manifestation of an if-else block as long as you remember to put the breaks at the end of each case to prevent more than one case from running. So that's the switch statement, and hopefully you can get comfortable, you know, building up your own examples with that, because it's a helpful technique to have, and it's just another alternative to using if-else. It's just another way of comparing a particular variable or expression against possible values, and then coming up with cases for what to do as a result of what the values are, and then coming up with the catch-all, with the default, like an else condition, if none of the case values worked out. So I think that's enough for now. From UMills 3, thanks for watching, and from UMills 3, Please subscribe.